Oh, welcome back everyone. I'm just making a video here to help you with some work out of the textbook to help you solve equations algebraically. What I want to teach you here is to think about how to think about and write the steps to create a bit of a sequence to help someone else looking outside look and see on the page the steps you've taken and how you've got to your answer. Okay, now you might not see that as worthwhile, but believe me, things will get more complicated where you cannot see the answer straight away. You can't solve things by inspection, and you have to employ a couple of these techniques to unwind it a little bit, and then suddenly you might be able to look inside and see the answer. So what I've got here, and I spoke about this in the last video, so this idea of unwinding things, I've got a card here. Let's build it up first. Like I was talking in the last video, if I have x equals 3, I can create an equivalent equation by multiplying both sides by 2. So then I get something that looks like this, 2x plus 6 equals 6, sorry. And then I say, oh, hang on a minute, let's just make it look a little bit harder again and see how students handle this. And we'll add 4 to both sides. So what we had was 2x equals 6, and now I've added 4 to both sides, so I've got a plus 4 there, so there's a clue. And what was 6 there, I had to add 4 to it. I'm not going to write that, so I'm just going to write 10 there. And so someone in the creation of all these questions has done exactly that, and now it's your job to unwind it. And here we are talking, and we're going to apply, do things in a certain way, right? The first thing I look at is I see this plus 4, so hey, what happens if I did the opposite operation of adding 4, and if I subtract 4 from both sides, I can unwind, whoops, I've gone one step too far, I can unwind what I just did. So I'll wind it back to this card, and I've got 2x equals 6. And so I'd write that on my page. And then I think, oh, I'm looking here, I've got another clue. I'm seeing if I divide both sides by 2, I'll end up with x equals 3. Remembering back, when I created this thing, I multiplied both sides by 2. All right? Just got to grab the right card here. But now I'm unwinding it, and then I get back to what I originally started with. And that's what I write as my answer. X, the value of x is equal to 3. All right, so I'm going to show you those moves, and I'm going to show you how you set it out. And I'm going to just say to you, it's like when I see things written on the page, I kind of think of it as a conversation that's taking place, like when we read a book. Okay, no one writes a book and starts with the first word and then pretends to write 200 pages of something else, and then you get to the last page and there's one more word and there's a full stop. Okay, and you're left wondering what happened in between. All right, so it's your job to document what the steps are and how you went about it. All right. Now, I just want to talk about solving equations, and there's a few one-step equations. They're like warming up, and we can see the answer. So I think in this situation here, we've got 6m equals 54. We can all see the value of m is 9. Okay, so what, and this is a difficult sell, I guess, because you can see the answer and you can write down the answer. It's not encouraging you to unlock the puzzle or have to follow a process to unlock the puzzle. So what I do when I'm working algebraically is that I see that is the pronumerals multiplied by 6. So I think about the opposite operations, and I'm going to say this over and over again until I guess what I'm trying to do is articulate everything that I'm thinking about and saying. So I'll put a line through that because 6 goes into 6 once. It doesn't disappear. It turns into 1. And so we've just got the value of the pronumeral 1 times whatever. And we've got to come over to the right-hand side here and say things like 6 goes into 6 once. And 6 goes into 54 9 times. So there's my answer. And so that's going to be the kind of thing that I'm going to work through in this video. So let's try another one. In the textbook it's written like this, something like that. Seeing that, I would write this as, I wouldn't write it like this, I'd write it like this. And because that's multiplied, the opposite operation will be dividing by both sides by 6, and that's how I set it up. So I don't even need to write divide 6 on the side here like I've taught you in the previous video, or they've been getting you to see and use as your instructions in the previous work. So 6 goes into 6 exactly once, and it goes into 24 exactly 4 times. So my value of j there is 4. Now I can come back up and check, and that's worth doing really quickly so you don't make a mistake. 6 times 4 is 24. So come back to your original equation and just double check. And for example, we've got something written here in the textbook like this. I wouldn't write it like that. I would set it up as a fraction. I like using fractions. You can see from my previous example here, and that's equal to 1. So this pronumeral is being divided by 5, so the opposite operation is multiplying by 5 on both sides. So I'm going to do that, and look, with a stroke of a pen, those 5s will cancel each other out, and I'm left with just the pronumeral by itself. So k is equal to 5. Now we're doing two-step equations here, and we're solving for two-step equations, and it's worth remembering BODMAS because it helps us see what to do when. So for example, we might have 8q plus 10 equals 98. All right. So my first move here would be thinking about unwinding this. I want to get a value of q by itself, and that's where that work for equivalent fractions come in handy, because I can start to think about unwinding this, and my first move would be subtract 10 from both sides. I set it up like this because I can put a line through that and say, well, you know, we had 10, we subtracted 10, and now that's 0. So I'm just left with 8 times q on the left-hand side, and I crunch my numbers up here. The reason I write it up here is because it's so easy to forget, and you could just come down here and write 98, and you'd get this thing wrong when we need to write 88. Now, this multiplied by 8, so the opposite operation is dividing both sides by 8, and I get a value of q. 8 goes into 8 once and goes in here 11 times. So my value of q is 11, and I would quickly come back up here and just check that. That's 88 plus the 10 is equal to 98. So it does work, and everything looks like a mess now after I've done all that. So let's try a few more, and I'll try and neaten things up now and just try to give you a sort of flow of the way I would be setting things up. And let's try this. Now, I'm looking at this number here, and I'm seeing the 4 out of the front of all the brackets, and BODMAS tells me I've got to do the work inside the brackets first. And so when I'm unwinding this, it's actually the last thing I need to do. So my first move here, having checked I've got 80 on the right hand side, I've got 4 over this side, so I'm going to draw a big line for the vinculum and set up a fraction that looks like this. These guys are going to cancel, and now this is going to be divided by 4 as well. So the stuff in the brackets, I couldn't touch it, and now I can just write it without the brackets, put the equal sign in, and see how I'm trying to keep everything reasonably neat. I can still see my numbers underneath the pen marks. So 4 goes into 4 once, and it goes in here, 4 goes in there 20 times. So I'm left with this. Now the job's easy. Now perhaps I knew the answer here. I knew that might have been 12, so I could have come down here and wrote y equals 12 as my final answer. Knowing that is good, because these questions I don't think are that difficult. You can solve them by inspection, and like I said before, it's really hard for some guys to do these other steps knowing that I can look into the equation and see what the value of the pronumeral is. So here's the last little step. What we're actually thinking about here algebraically is, what is the operation that's required to get the pronumeral all by itself? And I'm looking here to see that's plus 8. The opposite operation of adding 8 is subtracting 8. So I made my little marks here to say that I'm subtracting 8 from both sides. And there's my final answer. And I've kind of neatened it up from the last example. And if I want to check, I can now, instead of drawing over things, I might go like this: 12 plus 8, and inside the brackets using BODMaths, that's going to be 20, and 4 times 20 is equal to 80. Yes, I've got the right values. And that's the other thing you can do. You can always double check that you've got the right answer. Okay, so I'm going to do one more. I think I've got enough room here to do it, and it's a kind of a different setup. It looks like this: plus 9 is equal to 10. Now, solving by inspection, I could come down here and write k equals 4. All right, so I can see up the top here, when I look here, perhaps if I covered that up, something plus 9 has got to be equal to 10. So all this here has to equal 1. And to do that, we know it's going to be 4 divided by 4. All right, but working algebraically, we want to know what the steps are, what steps are involved here in unwinding all this. So I'm going to subtract 9 from both sides. That's my first move. And I'm left with the step in the middle, and that is 10 minus 9 is 1. And what is the next move here? It's I'm multiplying both sides by 4, so those guys cancel there. And that would be my workings to demonstrate to everyone what I've done, okay? And just be really careful about that, because you get these types of questions and you get 1 mark here for the answer, and there's another mark floating around for showing and demonstrating your working. So you might be really good at this, and you might be good at solving equations by inspection, but you might not do so well on a test because you haven't taken the time to show your workings. The final part of this video, I suggest that if you're grappling with what I've said so far, you need to stop and work through that and get good at that and maybe come back to this part of the video once you're good at that, because where's all this leading to? And the next step of understanding how to solve equations is we've got this set up here. We've got x as a pronumeral, but it appears on both sides of the equation. And how do we get an answer here that ends up being x equals something? Okay. It's a little bit tricky. How do we go about the business of deciding and guessing what the value of x is? It's really hard because you've got the left-hand side, you've got something to work out there and change. And so this is where the algebra and the manipulation of the equations becomes important. So what I want is, if you look down here at the final bit here, I want a letter on the left-hand side, and then I want it equal to some value on the right-hand side. So my first move here will be subtracting 3x from both sides. And that's how I set it up. I've just written that up there, and 3x subtract 3x, well, that's 0. Okay, so I want to shift the numbers. I've got plus 2 over here, so I might subtract 2 from both sides. And the same deal happens there. It's a kind of a neat mess, so what I'm going to do next is write out what I've got. This is 2x. 5x subtract 3x leaves us with 2x's. Okay, and on this side we've just got numbers, and we've got 10 subtract 2, which is 8. Okay, so I think my next step will be dividing both sides by 2, and then my value of x will be 4.